Interesting stuff, some maths into science. We always, whenever we have numbers, no, we try to represent it in a better way, and that's where graphs come into picture. So I'm sure you would have seen different types of graphs, so you know how to draw it. Let's revise it quickly. Have a look at this graph. What is plotted? I have one part. This is always called as the y-axis. This is my x-axis. So in this graph, which is favorite color of students, I always mention a scale. Very, 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 very important. If you're not giving me the scale, it's trouble. I don't know how much are you estimating. Okay. So now on this graph, what do I see? I have color red, yellow, blue, green, and on the other axis I have number of students. And what I see, these are bars. Okay, it's not a line, it's not a dot, it's not a curve, it's not a circle, it's a bar. It's a rectangle bar. So this is a bar graph. Another version of graph, this graphical representation, another version. Have a look at this. We have studied this composition of air, 78% nitrogen, 21% oxygen, and some portion of other gases. Doesn't it look like a pie that you eat? Yes. So this is a pie chart. This is also a graphical representation. Pie chart. One more graph. Oh, what do I have? Again, I have some x-axis. Again, I have some y-axis. Some years mentioned on the x-axis. Number of potatoes that are grown or maybe yielded. And I have plotted dots, and then there is a small line that is going up and down, connecting those dots. This type of graph is known as a line graph. So in this lesson, we were talking about speed, distance, time. This distance versus time. How much distance and how much time? We always use a line graph. Okay, so distance time graph would be a line graph. In the next slide, we will see how to draw a line graph, how to make a line graph. So distance versus time graph, the slope of the graph will give me nothing but speed. Okay, let's see how. First thing, what should a graph have? It should have a title. I should know what I'm drawing. Is it distance time graph, or is it some potatoes and years, or is it colors and students, or is it birthdays and something like that? I know it's a distance time graph. Okay, so title, very, very important. Scale. What am I considering on x-axis? What am I considering on y-axis? How much centimeter is how much units? That is the scale. Okay. And x and y-axis with proper labels and units. Have a look at this graph. So in this case, what do you think will be my scale? So my scale would be something like this. X-axis, where I say 1 centimeter, 0 to 5, that is 1 centimeter, is equal to how much time? 5 seconds. So every 1 centimeter is equal to 5 seconds. This is on x-axis. What will be on the y-axis? Y-axis, I will say 1 centimeter again is equal to how much? 5 meters. See this? 5 meters. So this scale has to be there on every graph on the top right hand corner. This is where you should be putting in the scale. If you are drawing a graph without scale, that's incorrect. Okay. Now see, now look at the graph and tell me, do you think this is uniform motion or non-uniform motion, children? We have studied uniform and non-uniform motion, isn't it? Now see, let's try and interpret the graph. Maybe when the object or that car started moving from 0, it went on high speed. Less time, more distance. 5 seconds, it covered 15 meters high speed. So this is A, high speed. When it was in that transition towards C, B to C, it was moving. It did not stop. It was moving. But now for the next 10 seconds, it covered only 5 meters. So the speed slowed down. When at C, what do you think has happened at C? Oh, the time was going on, but was the distance moving? No, which means the object was stationary. The object stopped. And now at D, the time is going on. Although we are coming down, the time is going on and on and on and on. But is the speed increasing or decreasing? Maybe the object is coming to a stop because this is where we started from. So the object comes back to the starting position. Has it covered some distance at this second? Yes. It's not here. It has moved. Okay, so it initially went super fast, slowed down, stopped, and came back to the original point again. This is how I interpret a distance time graph. Okay. Let's do one numerical on speed, distance, and time. Car starts from Pune at 11 a.m., travels at a speed of 40 kilometers per hour. How long will it take to reach Mahabaleshwar, which is at a distance of 120 kilometers, provided it stops for a short break of 20 minutes in the journey and travels at the same speed later? So initially it started with 40 kilometers per hour. Somewhere it took a break of 20 minutes and again it went ahead with 40 kilometers per hour. Give me the exact time when would it arrive at Mahabaleshwar. Whenever you have such a numerical, first thing you should do is extract data. Extract data in terms of what is given. I know speed is given. How much? 40 kilometer. Is the speed same throughout the journey? Yes. So before stop and after stop, same speed. What is the distance that the car has to move? 120 kilometers. Why 120? Because the car starts from Pune, goes to Mahabaleshwar, which is at a distance of 120. And we have to find out how much time. What should I do? You know the formula. Speed is equal to distance upon time. Distance divided by time. I'm just rearranging the term, mathematical operations. Time is equal to distance upon speed. I'm just moving things up and down, numerator, denominator. I get distance upon speed. Plug in the values. Distance I know 120 kilometers, speed I know 40. Now over here in this numerical, both the quantities, 120 kilometers and 40 kilometers, they bear the same unit. If they are not of the same unit, you have to make them, you'll have to convert them. Like if I tell you that the distance was 120 meters, then you'll have to make it into kilometers. Or if I give you this is 30 meter per hours, you'll have to convert it into kilometer per hours. That conversions you'll have to work on. This numerical, there is no conversion involved. So 120 divided by 40, that gives me 3 hours, which means the journey from Pune to Mahabaleshwar is going to take 3 hours. Okay. Now see, give the exact time of arrival of Mahabaleshwar. Now if you just take it this way, 11 o'clock if the person started, 3 hours later, 11, 12, 1, 2. 2 o'clock he should be in Mahabaleshwar. Will that be the correct answer? No, because there was a short break of 20 minutes. So if I will equate all these things, if I analyze these things, where do I get it to? I'll get it as a break time of 20 minutes added up. So total time from transit was 3 hours 20 minutes. Time taken to reach Mahabaleshwar would be 2:20 p.m. Make sure you also write the units properly. So this is where we come to the end of the lesson.